Right, we're taking a look at elimination method for solving simultaneous equations. So first thing is, how do you identify these? Well, usually you're given two equations or you've had to find them or create them with x and y and an x and y, or maybe an a and a b and an a and a b, but two variables unknowns that you need to solve for. So I'm going to do three examples in this video, starting with kind of easiest and then getting progressively more difficult. So feel free to jump ahead and try out the harder ones if you'd like to. But let's start off with question 1. So question 1 here. Question 1, we have 2x plus y equals 12 and x plus y equals 7. So for the elimination method, our aim is to get rid of one of the variables. And we can choose, and you always have this choice, we can choose to get rid of x or to get rid of y. So I'm going to choose in this case to eliminate y. Right, now you might have chosen to eliminate x, and that's totally fine. And you can even try this after doing that, but I'm going to eliminate y. So in order to eliminate y, I'm going to look at these two equations, and I'm going to say, look, the number in front of the y here at the moment, I'll just write it in blue, is the number 1. And this is also the number 1. So what I'd like to do is I'm going to make them the same number, so they already are. Okay, so I don't need to do anything there. But I'd like to change the sign. So this is a positive, and I'm going to change this to be a negative. So in order to do that, I'm going to have my little thinking cap on, and I'm going to have my little thought bubble, and I'm going to say this line here, to make this a negative minus 1, I'm going to multiply it by minus 1. So that's me thinking here. So I'm going to multiply this entire line by minus 1. So I'm going to rewrite these two lines. So what I like to do as well is I'll often number these 1 and 2 for myself, so I don't mix them up as I go. So equation 1, I'm doing nothing to. I'm just leaving it alone. So I'm going to write 2x plus y equals 12. So I haven't changed the first equation. The second equation, I'm multiplying everything by minus 1. So x by minus 1 would be minus x. Y by minus 1 would be minus y. You'll notice I'm not writing in the ones, you don't have to. And 7 by minus 1 would be minus 7. Okay, cool. So now that I've done that, I've changed the signs of everything here. I'm going to have another thought and do the following. So, and just remember, this is my second equation. So what I'm going to do now is I'm going to add these two lines. And I'm going to have a little thought bubble here. I would always write what I'm doing here in a thought bubble. Okay, because it'll remind me if I'm checking over later during the exam or during my test. But I'm going to add these, and I'm doing a little down arrow to tell me that I'm adding the columns. So I'm going to add the x's, the y's, and the numbers. So just watch your signs. 2x minus x. So 2 apples take away an apple, which just leave you with 1x or 1 apple. A y plus y minus y, and they cancel. And this is what I mean by eliminate y. Because they have the same number but opposite signs, they cancel. 12 minus 7 is going to give me 5. So I get x equals 5. And hey presto, I'm about 70% of the way through this problem. I found the value of x, so now I need to find the value of y. So how do I do that? Well, I'm going to sub x into equation 1 or equation 2. Now, it actually doesn't matter which one you do it in, but I'm going to say let's sub x into equation 1, right? You can check it in either and you'll get it right, so don't worry. But let's just have a go. So I'm going to write the equation 1, 2x plus y equals 12. And I'm going to replace the x with the number I just found, which was 5. So I'm saying 2 bracket 5 plus y equals 12. Now take your time, use a calculator if you need to, don't be a champ. Make sure to put a bracket, because when we get to negative numbers, it'll screw it up in your calculator. But 2 by 5 will give me 10, plus y is 12. And in order to get rid of the 10 on the left-hand side, I would subtract 10, and if I do it on the left, I have to do it on the right. So I'll get down to y equals 2. And if you're, that type of student that's like, I'm done now, I'm tired, you can walk away and there's a good chance you might be right. But I'm kind of a bit more cautious. I'm not sure if I'm right. So I'm going to do a check. And whenever we do a check, we're going to check x and y in the other equation. So if I subbed x into 1, then I'm going to check them both in 2. Okay, so all I do is I write equation 2, x plus y equals 7. And I replace in my numbers, x was 5, y was 2. Does 5 plus 2 equal 7? Well, hey presto, it does. I'm delighted. It means I have the answers correct. don't forget to answer the question as asked in an exam. So, for example, they might have said, give your answers for x, or give your answers as a coordinate. So, or give your answer for x and y. So you can list it as x equals 5, y equals 2. Or if you ask for a coordinate, you'd say 5, 2. Always remembering to put your x coordinate first and your y coordinate second. Okay, so that's the first example of how to solve a problem of simultaneous equations via the elimination method. Let's try a harder example. So question 2. Here I have 3x plus 2y equals 0 and 4x minus 3y equals minus 17. Now, what you'll notice is neither of these numbers, if I choose to eliminate y, they're not the same number. If I eliminate x, they're not the same number. Okay, so what I'm going to do this time is I'm going to have to multiply both lines by something to get them to cancel. So you have a choice. Remember, the first thing is you decide what you'd like to eliminate. Now, just to vary things up, I'm going to say this time I'm going to eliminate x. You might say, why didn't you do y? It's a bit easier. I'm just going to say, look, I'm going to show it doesn't matter. So in order to eliminate x, I need these both to be the same number. So it's a 3 and a 4 currently. So I think, what number do 3 and 4 both go into? And they both divide into equally, and they both go into the number 12. So what I'm going to do is I'm going to say, what would I have to multiply this line by to make it 12? So what would I multiply the top line by to make 12? I'd have to multiply everything by 4. So 3 by 4 would give me 12x. Now, I'm going to also do my thinking for the bottom line. I'd have to multiply this line by 3 to make this a 12, but I want this to be a plus 12 and I want this one to be a minus 12. So I'm going to multiply this by minus 3 to change the sign. Now, if you decided to eliminate the y's, you won't have to multiply by a minus. It'll already be a minus. So I'm going to just number my equations so I don't get lost. So there's equation 1 and 2. So I'm going to rewrite out my new equation 1 and 2. So the first one, I'm multiplying everything by 4. So 3 by 4 is 12x, and 2y by 4 is plus 8y. Be careful with this one. 0 by 4 is 0. Here, minus 3 by each of these. So minus 3 by 4x is minus 12x. Minus 3 by minus 3y is plus 9y. And minus 3 by minus 17. And definitely, don't be a champ. Whip out the calculator if you need to. There's absolutely no shame in double checking this on a calculator. But I think it's positive 51. Now I have the x's as the same, so I can actually do my eliminate x. So these guys are going to eliminate when I add them as a column, but I'm just going to put in this reminder for me what I'm doing. I'm adding down a column. So these guys add. If you want, you can put a line through them. That's perfectly fine. Doesn't really matter. Some people like that. 8 and 9 is going to give me 17y. 0 and 51 is just 51. So 17y is 51. So 17 by a number is 51. So I'm going to divide both sides by 17. So I get y is 51 over 17. And if I plug that in my calculator, or just do the maths, I'm going to figure out that y is 3. Okay, so how has this been more challenging than the first one? Well, we've had to multiply both lines by a number, find a number they both go into, and then do the exact same stuff as before. So as before, I'm now going to sub y, because last time I was subbing x, but this time I'm subbing y into one of the equations, and I'm going to sub it into equation, I'll sub it into equation 1 again, sure, no harm. So I'm going to say 3x plus 2y equals 0. I always like to write the equation and then fill it in. 3x plus 2 by my y, which was the number 3, equals 0. 3x plus 6 equals 0. I'm trying to get x alone, so I will subtract 6 off both sides. So I get 3x equals to negative 6. And then I'm going to divide both sides by 3. They're going to cancel here, and I get x is minus 6 over 3, which simplifies to be x is minus 2. Happy days. Now, I'm not sure I'm right or I'm done, so I'm going to do a check. So I'm going to check both, or x and y, in the other equation. So if I subbed it into this one, I check it in the other one. Now, the reason for that is if you sub it back into the first one and you've made a mistake, you'll end up getting the same answer that you got, which will make you think you're right, but actually you could be wrong. So always sub it into the other equation. So check both in number 2. So 4x minus 3y equals minus 17. 4 by minus 2 minus 3 by 3 equals minus 17. You can plug this whole side into your calculator, okay, but I'll just do it out. Minus 8 minus 9, does that equal minus 17? Why, yes it does. So I've got my 2 answers. I'm delighted with myself. Again, make sure if you're going for these, just read how the question is. So when you're giving your answers, does the examiner just want to know what they are, or do they want it as a coordinate? And remember, if it's a coordinate, it's always your x first, then your y. Okay, so that's it for a slightly harder example. More common one that you see here is where you have to multiply the top and the bottom line by a certain number. Okay, let's take a look at the last example. So here we have one and it has the dreaded fractions. Okay, already your heart might be getting into palpitations. So my advice here, before we even worry about what they go into and yada, 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 I'm going to say, look, fractions upset us. So let's just rewrite this line. Now, the first line, how do I rewrite this to get rid of fractions? Well, I look at what's on the bottom, the denominator of each one, and I say, okay, look, if this is dividing by 3, then I'm going to multiply this by 3. I put a little bracket there in the sky. If I multiply this term by 3, I have to multiply all the terms by 3. So I'm going to do this term, and this term by 3. Now, I'm not quite done yet because I'm going to try to do this in one swoop to save a bit of time. It's also dividing by 2 in this fraction. So I'd multiply this term, and this term by 2. Now, I don't need to do the 3 again because I've already got it done by 3. So if, say, for example, this was the number 4 or number 5, you'd multiply it by 5 and so on. But just once you've done it, 3, 2, you're done. So now I'm going to get a different color. I'm going to get my green out, and I suggest a clicky pen for these. And I'm going to say this 3 cancels with that 3. This 2 cancels with this 2. This 3 cancels with this 3. And I'm just going to have a look here. It's now 2 times the top. So 2 by 2 would give me 4x. So I'm going to rewrite my new, just going to draw a line here, my new equations 1 and 2 again. So this becomes 2 by 2, which is 4x. This becomes 3 by 3, which is 9y. And this becomes 2 by 4, which is 8. Okay. Now it's nice and neat, and it's starting to look like the previous question. The second one I don't need to adjust. Now you could be asked to, or you could have to adjust it as well, in which case you would, but here I'm just going to leave it like that. Now, I'm ready to get jumping into this question, and I need to just make a choice. What would I like to eliminate? Will I eliminate my x or eliminate my y? I'm going to eliminate y this time, okay? Again, doesn't matter, your choice, but I'm just showing I'm going to eliminate y. So if I want to eliminate y, I already have 9, this is 3, so I'm going to say I'm going to multiply this bottom line by minus 3. So my new equation, the top equation doesn't change. My bottom equation, or equation 2, becomes 2 by minus 3. So 2 by minus 3 is minus 6x. And minus 3 by plus 3 is minus 9y. Minus 3 by 3 is minus 9. So just watch your signs. Use a calculator if you need to. I'm going to add these lines vertically. So I draw a line, and I'm going to put my thought bubble, add, and I do a little arrow down. 4x adding minus 6x, or 4x take away 6x. Just be careful with this. It's minus 2x. The 9y and the 9y cancel because they're plus 9y minus 9y. 8 minus 9y is minus 1. Okay, I've got a minus 2 here multiplying with the x, so I'm going to divide both sides by minus 2. And I end up getting x is minus 1 over minus 2, which means it's a half. Now you might be getting nervous going, uh-oh, have I made a mistake? I got a fraction. Well, look, stick with it. Okay, maybe you have made the mistake, we need to go back and check, but we'll just continue on because we're going to check at the end anyway. So let's do it before. We're going to sub x. Now, in this case, I think it looks a lot easier to sub this into the second equation than the first ugly looking equation. So I'm going to sub it into equation 2 this time. So sub x into 2. So I go 2x plus 3y equals 3. 2 times a half plus 3y equals 3. 2 times a half just becomes 1. You can check that in your calculator. Plus 3y equals 3. I subtract 1 off both sides. Again, you might notice bringing it across the line, change the sign. Makes me a little bit sick every time I say it, but it's a totally fine method. Divide both sides by 3, and I get y is 2/3. These 3's cancel. Y is 2 over 3. Now again, I got fractions. I don't love fractions, you know, it's a bit upsetting sometimes. So I'm just going to do another check. So I'm going to check both in 1. Now, if the examiner asked you actually specifically to verify, then you would have to make sure to do this. But if he doesn't, it's just good practice for yourself. So I'm going to say 2 over 3x plus 3 over 2y equals 4 over 3. So that was the first equation, back to the very original. And it's always safer. Sometimes students ask me, can I use this one? You can, but if you'd made a mistake, then you might follow on and seem like you get it right. So I always just check the original. Now, 2 over 3 times a half, that was my x value, plus 3 over 2 times 2 over 3, does that equal 4 over 3? Now, this might upset you. You can just plug the left-hand side into a calculator. You don't need to actually be a champ and do it, but I'm going to be a champ and do it. The 2's here will cancel, the 3's here will cancel, the 2's here will cancel. This will become 1. 1 plus a third, so 1/3 plus 1, does that equal 4 over 3? It certainly does. So again, I have my correct answers. So at the end, I can again just double check. Does he ask for it in terms of x and y? For my answers, if it's x, I tell him it's a half. I tell him y is 2 over 3. If he wants coordinates, I put it in x first, then y, and hey presto, I'm done. So there is 3 worked examples for solving simultaneous equations using the elimination method. Best of luck.